All right, welcome back. Let's take a look at one more example here. We're going back to a easier to work with function. We're going to go back to an easier to work with function. We're going to go a little bit further than just finding the derivative this time. So let's consider the function here. F of x equals 2x to the fourth minus 4x squared plus 5. Right. So first thing we're going to ask about our function is let's find our derivative. And hopefully now at this point, as we've worked through these different examples, this is a pretty easy derivative to find. 2x to the fourth minus 4x squared plus 5. So we're just using our power rule. So the derivative of 2x to the fourth, we bring the 4 down. 2 times 4 is 8. Drop it by 1, get 8x cubed. And then 4x squared, bring the 2 down. 4 and 2 would be 8. And drop the exponent by 1 would leave us with just an 8x. And then 5, that's constant, so its derivative is 0. So the first question there, the derivative is f prime equals 8x cubed minus 8x. So pretty straightforward, we're just finding the derivative there. Then we go on here in part B and we ask the question, find the slope of the tangent line at x equals negative 2. So remember, the slope of the tangent line is quite simply just the derivative. Right? We're literally just looking for the derivative. So we just evaluate the derivative at negative 2. So let's go into the derivative, replace x with negative 2. So 8 times negative 2 to the third minus 8 times negative 2. And then we just go through and make that computation. Negative 2 to the third will be a negative 8 times 8 will be negative 64. And then a minus 8 times a minus 2 will be plus 16, so that f prime of negative 2 is simply just negative 48. So that is the slope of the tangent line at negative 2. The slope is just simply negative 48. Slope is simply just negative 48. Okay. And we ask a part C to our problem. Instead of wanting to just know the slope of the tangent line, we might want to actually know the tangent line. So we want to find the equation of the tangent line at x equals negative 2. So we already know the slope. That's what we just found in the last problem. The other thing we need to know is a point on our graph. Well, since we know our x value is negative 2, we can go back to our original function. Plug negative 2 in for x to get the y value. And so that's what we do. F of negative 2 equals 2x to the fourth, so 2 times negative 2 to the fourth. And then it was minus 4x squared minus 4 times negative 2 squared plus 5. So we go through and we make that computation. Negative 2 to the fourth would be positive 16 times 2 would be 32. Negative 2 squared would be 4. 4 and 4 would be 16 when we multiply, plus 5. So we're going to end up getting f of negative 2 equals 21. So we know that we're dealing with the point negative 2 for x, 21 for y. And so now we're ready to find the equation of the line. Equation of line. So remember, that's when we go to our slope-intercept form. Y equals mx plus b. And we plug our information in. 21 equals our slope, negative 48, negative 2, plus b. And then we just simplify. 21 equals 96 plus b. And we solve for b. Right, subtracting 96 from both sides until we get b equals negative 75. So the equation of the tangent line is y equals negative 48x minus 75. Negative 48x minus 75. Okay. So now we have the equation of our tangent line. And this problem goes and adds one more part to it, as if we haven't done enough yet. We found the slope of the tangent line. We've now found the equation of the tangent line. There is one additional question that we are asked, and that is to find all the x values where the tangent line is horizontal. Find all the x values where the tangent line is horizontal. In other words, we want to know all of the places where the slope of the tangent line is 0. Okay. Horizontal lines will be flat, so they'd have a slope of 0. So that's what we're looking for. When is the slope of the tangent line 0? So we're looking for when is the derivative 0. And so we would set our derivative 8x cubed minus 8x equal to 0. Right? And now we're faced with a polynomial equation to solve here. Fortunately, this is not going to be a terribly hard one to solve because we have an 8 that will go into both of those terms, and we have an x that will go into both of those terms. So we can pull out an 8x. And so we do that. 8x, x squared minus 1 equals 0. So either 8x equals 0 or x squared minus 1 equals 0. 8x equals 0 leads us to the solution x is 0. And x squared minus 1 equals 0. We would bring the 1 over, apply our square root, right, and we would get the two solutions there, plus or minus 1. So there are 3 points, 3 x values, where the slope of the tangent line is 0. The slope of the tangent line is 0 for our function. The slope of the tangent line is 0. Now, That's going to be of interest to us a little later on, a little bit later on. Uh, because if I go to the graph of this thing, the values I've just found were at -1, at 0, and at 1. Those are the three places there where the graph, those are the three places there where the graph has horizontal tangent lines. And what I want you to notice here about those as we kind of move along, hit that point, all right, that's kind of a hump on the graph where you have that horizontal tangent line. It turns around. Same thing here, this one turns around. And again, the last one, it turns around. So those points where we have horizontal tangent lines are going to be of interest to us a little later on when we start looking at applications of derivatives. But for now, I just wanted to kind of show you graphically what can happen at these horizontal tangent lines, places where the derivative happens to be 0.